Hello everyone and welcome to our edition on top 10 security features for a zero trust architecture in the Red Hat Enterprise Linux platform environment. I am Jean van der Breggen. I'm a RHEL advocate with the RHEL platform team, and with me I have Alessandro Rossi.
Hello everyone and welcome to this event. I'm Alessandro Rossi and I'm a RHEL advocate as well in the RHEL platform team. Angel.
Hi, welcome everyone. I am Angel de Bustos, working with John and Alessandro in the same team.
Thank you, Angel. And what are we going to discuss today? We have 10 zero trust architecture points that we're going to discuss today. You will see we've got actually 11 there because we included Red Hat Satellite in there as well. But we're going to talk about how do we actually implement a zero trust architecture within your RHEL environment, going from things like image mode and image builder, SE Linux, FA policy D, crypto policies, and so forth. So let's just start with what is a zero trust architecture. Just get an idea about what are we talking about. So traditional security models, I can almost say it's like everybody that is in your building or in your castle have key to every single door that's out there. There's no privacy. They can walk in and out. They can go across. That is a traditional security model that we've always used within our environments, that we've actually trusted people that they know what they're doing and have access to that environment. But when we go to a zero trust security model, we actually deny everything. If you want to have access to a certain room, you've got to go down to the security office and ask for access. Get the key, get the access environment, and be able to go in. And that is isolating all the different environments and be able to say, based on your identity, based on your authorization, based on the authentication you have, do you have, for a duration, access to certain aspects within the operating system? And that is where we start thinking about a zero trust security model. It does not mean that we will not allow anyone in, but from the outset, it's deny all, verify all, and then only give access for the specific task, specific duration that that person needs to be able to perform what needs to be performed. And it all starts right at the beginning. When we start building our systems, that is when we start thinking about how do we implement a zero trust architecture into that. Using curated, trusted, up-to-date content, making sure that when we start with compliance baselines like CIS, OpenSCAP, so forth, that is baked in right from the start. We protect our environment, not just based on policies and access and so forth, but also the location. Where's that data living? Who has access to it? What is the system purpose of this? How critical is the information sitting within that environment to our organization? How secret do we need to keep it and be able to protect that? And then if your environment is just as strong as you know how it is. So you need to be able to verify it against your compliance issues, against best practices you have, making sure that authentications are being recorded, that you can always go back and ensure that whenever something happens, that you still can be able to verify who is the person who did what in your environment, and did they have access in the right place. And if they didn't, understand where the holes are and go and fix it. So, as I said, we built it in from the start, and it really starts in the top left-hand corner when we start thinking about designing our new systems. Is we got to think immediately about the identity, security, authentication, authorization, system roles that system is going to have, and how do we actually think about it right from the start when we start building that, where we're going into the next one. And that's almost like building a house, making sure that you have the alarm systems in there and the right locks and the cameras and everything else that you build into that environment, that infrastructure is there from the start. And then run that with the enhanced security capabilities. And this is always where we get things wrong, because we run that and we sort of think, okay, everything is placed, I've built it, I've designed it, and then we leave the front door open. That is not the idea. When we run it, we constantly need to manage it and look after it and making sure that all the security compliance and things that we put in there is compliant, is ready, is being checked, so that when anything goes wrong, we can actually go back and say, yes, we can adapt, update, remediate what we need to do, bring that back into our design. And this is a full circle we're going through every day and making sure that when we actually want to secure environments and harden our environments, we actually do it from the start, but it's a continuous cycle that never stops.
And this is actually what I love the most about this loop, because it really shows you how to cover all the aspects of the life cycle. It's not just about identities, it's not just about security, it's not just about network rules or firewall rules. It's just about having a whole process that is not just involving the technology, because we are not going to just talk about technology today. It's about trying to understand how people, processes, and technology can work together to really link to the Zero Trust architecture concept. And what we are going to do is to start, of course, with the design and build phase. And in this specific session, we are going to talk about one of the biggest news that came out with RHEL 10 and RHEL 9.6, that is image mode for RHEL. So when it comes about containers, we've heard a lot about containers. We know that application containers are now the standard on how developers ship their application and how we run their applications. But of course, we have something in the operating system that is how we know RHEL today. That is the classical package mode, where we install the system, deploy the system, and then we start customizing our systems and updates using the package manager. What if we can bring the best of the container technology, that is replicability, immutability, and the possibility to really shape how to create the container and what to bring inside the container, and we use containers as the source of truth for our installation, deployment, and management of our RHEL system. And this is exactly what we are going to do.
So Alessandro, if I understand correctly, what you're saying to me is I actually start with the whole build process as I do with containers. And when I deploy this out into where a RHEL server is going to run, I actually maintain drift and changes within it, because it all comes back to the source as we do with containers.
Exactly. This is exactly what happens. So the image, the container image, will become a unique source of truth for the content of the system and the updates of the system. So you can define it at the build phase, and then you could really shape and tailor the image based on your needs. You can also, and we will see this, you can also completely change the purpose of the system. So you can start from an application server and end up with a database. You will see, and we will see how easy it is to just manage updates with image mode.
And the key thing is, once it gets deployed at the end, it's a read-only system. So no one can change it. And that, again, is a key part of our security look at this, of saying that once it's deployed, is a secure environment.
Absolutely. And this leads us to the first real phase. That is exactly what we were talking about, the build phase. It's a container, after all, so we are not going to do any magic here. So on the left, you can see a classical container file or Docker file, how you want to name it. And we have something different here, a different base image. That is a tailored base image that contains some of the bits and pieces that are needed for a full system, so including a kernel driver, systemd, network manager, everything. And we will be able to exactly tailor our image exactly like an application. So we can install software, we can run security profile enforcing, we can add configuration, script, whatever, and we can just build it like we build any other application container. So you can use Podman, you can use Builda, you can use Docker, you can use containers by Apple. The process is exactly the same. And what you will end up is a complete defined image that we will be able to then use and start deploying our system. We will see that there is a new step that is introduced, and we will see that in the next phase. That is, of course, we are not going to use the container as a container. It's the source of truth of something. So we will need to convert it and make it work in our environment.
But now the question that we're always going to get from security people, Alessandro, is when do I harden my system that I want to deploy, because I take it this RHEL boot C that you've just pointed to is not a hardened system yet.
That's an amazing question, and the answer is you can do that at build phase. So you can end up with a hardened image starting from when you define it, because we have a dedicated version of OpenSCAP that is called OpenSCAP-IM, that is image mode, that will enforce security profiles, so PCI DSS, CIS, any profile that is available for the base RHEL system, and you will be able to apply it at build time. And this is where we are. So we are not doing any magic up to now. So we have a container file, we build our container image, we push our container image to the registry, and we are quite good to go. But it's time now to start introducing something different. That is how image mode works in RHEL. And one of the biggest things here is that, of course, we have a container image, but what can we do with a container image? We can not just run a 3 gigs or 4 gigs image just for the sake of running it. So we need to convert our container image into something that can be actionable and deployed on real systems. We have a dedicated tool that is called bootc image builder that will allow you to convert the container image into a QCOW image, an ISO file, an Azure instance, AWS instance, or a raw file if you want to do some more customizations, and then you can deploy it wherever in the hybrid cloud. So it can be on-premise, at the edge, virtualized, in the cloud, absolutely everywhere. Because at the end of the day, John, RHEL is still RHEL, right?
It's still RHEL. We're still going to run it in exactly the same place as where we've been running all our RHEL servers in the past. Yes, we can run it in a container. I would do that for testing, but the end point of where I want to deploy an image mode image is where we traditionally ran a RHEL sim, bare metal servers, virtual machines, cloud EC2 instances and Azure compute nodes. That is where the endpoint is.
Absolutely, yes. And the picture is now starting to get a bit better shape, because now we are in the moment where we built our container and we ended up installing RHEL on our devices. And when it comes to updates, we are going to tackle this in a moment. Here we go. If you notice on the left, we have a new component that is called bootc, and bootc is the art of image mode, because bootc manages all the life cycle of the image. It can be an upgrade, it can be a rollback, it can be, as we mentioned before, a complete change of the image that our system is referencing to install itself and to manage itself. The idea here, if you're using updates on your smartphone, the concept is exactly the same. You take only what's needed, a delta of the image. So have you changed the file? Have you added a package? Have you completely changed your version of the operating system? Absolutely, you can update it via bootc. And we know, John, how hard and time-consuming can updates be. Can you give us a brief overview of how long can it take an upgrade from, let's say, RHEL 9 to RHEL 10?
Well, I've been in situations where it can quite often take days because we're struggling with dependencies and all kinds of issues. The beauty of this is, of image mode, is I just change that from command that I had in my container file from RHEL 9 to RHEL 10, and it will start slotting in the RHEL 10 underneath my application. I rebuild that image, I can test it in a container, and if it runs, I can update the image. Don't redeploy. All I'm doing is just updating that image, bringing in the RHEL 10 parts underneath it. The application still lives on top of that. But you know what's the beauty, Alessandro? I have rollback. So if something goes wrong on that machine, all I do is switch it back to the old image that I had, and everything is back to what it was. And this is really makes our life a lot easier in terms of updating, deploying, securing our environments.
Yes, and what we always say is that it's not the new way of managing RHEL, it's an alternative to managing RHEL as we know it. So the rollback, to be honest, is one of the biggest thing here, because with the normal tools, the leap tool that we are using for in-place upgrades, you have no capability of rollback. You just need to restore a snapshot. You just need to restore your backup. There is a point, there is a threshold. Up to there, you cannot go back. And with bootc, it's just a matter of just switching entries in a bootloader and you are coming back with the old version of the operating system. So that's one of the most fascinating things about image mode. And now we have the full picture. So we know how to create an image, how to harden an image, how to deploy RHEL, and how we can easily manage RHEL. Of course, RHEL is still RHEL, so we can still use Ansible automation platform, we can still use Satellite to manage it, we can use Edge Manager to manage our devices. It's all up to how we want to shape the management part of our systems.
And in the end of the day, that whole deploy section that we have there in the top, you do that once. And that's when you start up your virtual machine or create your new EC2 instance, and that is where it's running. But the management side, that is the rolling feature that just keeps on going every time I do an update to the container file, update to my applications, update to patches and operating systems. And that management tool will just manage the whole time the delta differences between what is running currently in my virtual machine, for example, and what is currently in the container registry.
Yes, thank you, John. And this was just a teaser, because of course we have a lot of content, and John, I, and Engel worked a lot on this topic, and we have many webinars that you can go back and check, because every of them is recorded, so it's available at the links that you will find in the slide that we are going to share. And we also had a lot of content that you can start using right now. We have a dedicated demo page where you have a lot of use cases and way of working suggestions on how to better work with image mode. So it's not just about creating a simple container, but also some articulated use cases that takes more steps to get done. And of course, containers love CI/CD and automation. So we also have a collection of quick starts for the most common platforms like Ansible, like Tekton, like GitHub, GitLab, and you will be able to just clone the repository and start working with that. And of course,
And we have the labs. So
we
if
have
you
the labs.
want to try this out without compromising your machine or anything, you can go to our labs, and it's all spun up on the back end from our side. You just need a browser, and we take you step by step, instruction for instruction, how to get your first image mode RHEL environment up and running, and then being able to do all these things that we just spoke about, rollbacks and switches and all these beautiful things.
Right. So it's just a matter of getting started. And this is the moment where we are going to talk about another topic, the second topic of the day, that will be RHEL, Red Hat Lightspeed, with Angel.
Okay, so maybe you know Red Hat Lightspeed by its former name that was Red Hat Insights. Now its name is Red Hat Lightspeed. So in our daily routines, we all face the same issues. We suddenly are suffering from a performance problem. We don't know why, we don't know how to solve it. Nowadays, every day, due to the artificial intelligence era, new vulnerabilities have been discovered now and then. We don't know if they are affecting our system or not. We don't know if there are some kind of exploit that can be used to attack our systems. And of course, we have the problem with the configuration that must be, our system must be configured in the same way from the day one to the end of its life cycle. But sometimes we have to enter the system because we have some performance issue, we have to do some tasks, and we can change a bit the configuration, but in the end the configuration is not as good as it should be, and we do not know if all the systems are compliant with our configuration or our security requirements or not. Okay, we have all these problems, and we can solve this using Red Hat Lightspeed. Red Hat Lightspeed is a software, a tool that is included with your RHEL subscription. So that means that you don't know just to pay or to buy any other product to Red Hat. You are using RHEL, you can use Red Hat Lightspeed. We can manage all our system in a central point just to see how our systems are. I mean, the vulnerabilities we have, how the configuration is, if our systems are compliant, and what's is more important is that the configuration is checked against Red Hat database. So if we find that you can have some problem, some misconfiguration that can have some issues in the future and produce some features, some problems, sorry, in the future, you have all the information just how to fix this information, and you will provide it with an Ansible playbook just to remediate it, the problem you are facing.
And one of the beautiful things again with Lightspeed is that this manages not only on-premise environments, but you can have your cloud environments into that, you can have edge devices, and all of it comes together in a single pane of glass and a single console.
Right. So Red Hat Lightspeed is a software that you can use from the Red Hat Cloud, but you can also use on-prem without the need of sending information to the Red Hat service. Okay, these all of the features we have in Red Hat Lightspeed. You can see there are two with the on-prem label. That means that the advisor and the vulnerability features are available to be run on-prem. That means that you can use the advisor just to check your configuration to see if you can have some potential problems in the future about performance, availability, stability that can be harmful for your servers, and you will provide with the information to fix it before you have a problem. And you will be provided with an Ansible playbook just to remediate it. With the vulnerability feature, you will be able to see what security vulnerabilities are affecting your platform, or even if there are some exploits that can be used to attack your systems. With the compliance, you know, as in RHEL, we are including different security profiles just to check or to comply with these security standards like PCI-DSS, CIAs, etc. So you can check the compliance with these standards from Lightspeed, and you can remediate it as well. We have another tools like the malware detection tool, and which you can check your system just to see some malware is inside your system. That means that you can look for malware in your hard drive, in your file systems, or even in the memory in case some application is running with a malware running in memory. So you can check for both in your file system and in memory. You can patch your systems as well from Red Hat Lightspeed. Image Builder, I'm not going to tell you about Image Builder because my colleague John will be explaining you all the features and the advantages of Image Builder. With the cost management part, you can have a prediction about what are the costs of having your infrastructure in the cloud. Remember that Red Hat Lightspeed is able to manage servers that are run on your data center, in the cloud, or even in the edge. With the subscription manager feature, you will be able to have accountability about the number of subscriptions you are using for all the architectures, virtual machines, physical servers, either Intel or AMD servers, RHEL, IBM servers, mainframe, or PowerPC. So you can get all the information about all the subscriptions you are using, and you can integrate Red Hat Lightspeed with a lot of products from other vendors.
And I just want to add for the malware detection now, if you have a CrowdStrike account, you can integrate that with your CrowdStrike account and add in all the signatures from CrowdStrike to be able to help with malware detection as well.
You can skip in this part.
Okay.
So, Angel told us a little bit about Image Builder for RHEL. I'm just going to go a little bit deeper into that, but I honestly suggest you go onto the console.rhel.com, go to the RHEL section, and try this for yourself, because if you ever download an ISO image, then this is the place to go. So Image Builder is almost like a recipe book of building your base images that you want to deploy. And the key thing is that we will incorporate all the latest RPMs and patches and fixes from our content repository into that image at deployment time. You can pick whether you want to deploy this same image, so you create one blueprint for everything you want to deploy, or you can create multiple blueprints, but that blueprint you can deploy then into a bare metal server, into a virtual machine, into a cloud environment. We support Google, we support Oracle, we support Azure, AWS, wherever you want to go. But the key thing is, again, is coming back to what we said previously, security first. So you actually select the OpenSCAP profiles that you want to implement at build time. And you can actually build your own profile. It doesn't have to be a stock standard one. You can pick a profile and then start enabling, disabling, adding features into that. That profile gets baked into your image you want to deploy at that time. Configure and add users and groups and packages. Manages the firewall rules that you want to do in it. Custom scripts. The key thing at the end of the day is when you finish building that blueprint and you then push this image, for example, into an EC2 instance, that already has all the security features built into it. And that's immediately where we start with the zero trust architecture. It connects up immediately with your satellite environment or with your identity management environment, and being able to say, I'm a hardened, secure image ready for production. And there's multiple ways of doing this. The first one is using a command line on an on-premise environment. You need that with your Red Hat Enterprise Linux environment, but it's included in subscription. This is just tools that you add into it or install along with that. We have the fantastic web console. Again, makes it a lot easier for you to be able to do that. Not only the web console to be able to do image builder with, but the web console to manage your whole infrastructure or your whole server from that point of view in there. But again, very similar to what we have in the console side, where you can then select the different packages you want to install into that, the users and so forth. Again, that is included with your RHEL subscription. And then we have the image builder that is a hosted environment that is sitting on our environment at console.redhat.com. And for that, we have APIs into the cloud environment, so you can have a cloud hosted experience. There's no infrastructure required. Like I said, we immediately pick all the packages that you require, that you've selected, that is going to be built into your system from our content network, and that then creates a various amount of images that you can deploy into any endpoint where that RHEL server is going to run at the end of the day.
And as you might have heard during Red Hat Summit in May, we've announced the support for image mode in the image builder on premise, both with the command line and the web console, to just start integrating all this process that we've talked about before into something that can also be part of another pipeline that you already have by interacting with the API of the image builder part. So that's something that was announced at Summit. If you're curious about other announcements and the roadmap that is going to be for image builder and the great things that are coming, we have recordings, we have some live stream for the keynote and some sessions, so you can just go back or just contact us and we will be more than happy to discuss this with you.
And the next part is SE Linux. And SE Linux is always, I always say, this is the core of security within the Red Hat system, within your enterprise Linux environment. And Angel is going to take us a little bit further through the SE Linux features that we have.
Yeah. No, Linux incorporates with this mandatory access control. That means that system administrator will be responsible for configuring the security policies for the system, and that means that no one in the system will be able to modify that policy, even if the person who owns that object. That could be a file, a directory, or whatever. So, for instance, the normal thing is that users are allowed to bind processes to ports above the port 1024. If the administrators configure a policy that ports above that port 1024 port are not allowed to be bound, no one could be bound a process to that port.
And this is coming back to that example I said in the beginning of, a house or a castle or a building, is that with SE Linux, your building is locked, the drawbridge is up, the alarm is on, the guards are watching, the dogs are there. Everything is there to ensure that your environment stays safe and that everybody else who wants to get access gets access denied.
So we're going to see a couple of examples about how Linux can protect our system. The first one is we're going to check how we can block a process to bind a port, even that port is above the 1024 port that by default in normal systems, all users in the system can mount a process. So this is the copy console for Red Hat Enterprise Linux, and this is the terminal. We have an HTTP processes running, showing the test phase, and we can see that Apache is running in that system. Okay. Now we're going to change the configuration. And we're going to change the default port, this is the 80 port, to a different port. Now we're going to restart Apache, that just the new configuration is used. And we can see that we have a problem. This Apache is not starting. And we are not seeing the web page because Apache is not running. Now we're going to use a tool just to see what Linux error messages we can have. And now we can see that we have a problem with the port. This is due to the administrator has configured that Apache only could access the port which has a specific level, which is HTTP port T. We are now going to allow or to add that level to the new port for Apache, to the 9876 port. And now we are going to start Apache. So that means that Apache is allowed to bind that port. You can see that the new port has the right level, security context. We're going to start Apache. Now Apache can start because it is allowed to bind that port. And now we can see the web page showing in the new port. Okay, so we have just seen how we can stop a process to bind a specific port. And now we can do the same with files. So we can tell Apache it's allowed only to read some specific files on the system. So we can block processes to read files in the system unless that files have the specific security context, Linux label, and that configuration, that security context is configured by system administrators. Now we can see that Apache is running. We see an index file for Apache. We can see that this file has the security context admin home T. We are going to move this file to the directory where Apache reads its files, and we're going to see that the file has the security context admin home t. Apache is not allowed to read that kind of files. So we have reloaded the web page. So we're looking for sick Linux errors. We see that we have many of them. Those errors are due to the security context for that file is not the right one for Apache, so Apache is not able to read that file. So Linux is blocking Apache to read this file. So now we are going to change that file security context privileges. So the right Linux context, this HTTP syscontent T. And we can see that we are able to read the file. So we have seen how we can use Linux just to avoid some processes to bind to different ports, and we can restrict our processes to read specific files, and those security configurations are configured by system administrator. Linux is also able to configure multi-level security, which is used in very systems from the military, for instance, which requires a high level of security, but we are not covering that feature in this webinar.
And another important thing, if you remember about the CVEs that were out in April or May, if you remember, some of the remediation always involved the combination of SC Linux with other tools and kernel parameters to just mitigate those that were like super invasive CVEs and security issues. So when it comes to you disabling Linux, just take this choice very carefully, because it's something that is really helping you to manage and secure your systems. And now we are exploring one other tool that is something that can be easily integrated within your existing systems, that is FA Policy D. So we are just talking about files access policies that we can implement in our system to prevent external and malicious software to run in our system. So FA Policy D basically is based on a set of rules. You can define some of the rules that needs to be met when you are running a system and when you are running external programs, or when you're doing some changes in the files. Because one of the biggest things and the biggest threat is that someone gets access to your system and tries to sneak in and try to change the content of some base system executable files and binaries, and they can easily inject some malicious software and malicious code inside that. How do you prevent this? You can prevent this by, for instance, using FA Policy D to introduce hash checks on each and every file that is present at that specific time in time. You can check based on the RPM database which packages are installed, which binaries are coming from a specific RPM, and you can also prevent the execution and the opening of executable files from any part of the file system, so that you can really start creating that layers that John introduced us before. So it's not just about prevent getting access, but what happens when you get access to the system? What can you do inside the system? And FA Policy D is one of the, we would see, is one of the ways together with SC Linux and with the anti-intrusion detection systems that we have, to just be able to make some security and enforcements real. And of course, we have a demo. So in this demo that we prepared, we are going to tackle two main use cases. So the first is the execution of a malicious binary that is prevented by FA Policy D. And we can also see how we can detect a rogue binary, so something that was injected in one of the commands that we have in our system installed by default, because some malicious attackers tried to change a bit the code that was running inside of them. So starting with the first use case. So we have our fantastic system that is running. So it's the same system that Angel used before. But what we are going to do now is that, okay, someone got access to our system and is willing to run that fantastic malicious script. So let's first of all check if everything is good. So FA-policy-D is based on a database. So it has a database of rules that can be configured. And this can be extended at your wish. So you can add anything that you need on the top of that. So someone got access to our server and injected a malicious binary in the temporary directory. I'm a root and I can access this file. So this is basically the content of the webinar, but it's, we know that this is malicious because it doesn't look like so good. So what I can do is that with FA-policy-D, starting from scratch, I don't have the opportunity to run that binary. So this means that FA-policy-D just prevented any execution of that specific file directly within the database, because it was not in the database when the snapshot was taken. So we didn't allow that malicious file. But then our security team is so cool that just detected that it was a false positive. It was just John, Alessandro, and Angel doing some weird stuff in the system. So what they said is, okay, just add this as a trusted binary that we can run in our system. As you can see, that's exactly what we did. So we updated the database, and we can see now that our sysadmin user is able to just follow this webinar as well. So that's an easy way to just deny all, as John said at the beginning, deny all and start piece by piece to just add some of the things that we want to add because we need to run it. And the second use case is based on detecting a rogue binary. So someone got access to our system and tried to inject some bad code in one of our common tools that we are using. In that case, we are using less as a target binary. So we are now back in our server, and in this specific use case, we want to use the integrity check of FA-policy-D to just detect some changes that are injected by an attacker in the command that we probably use the most, that is more. And the first thing that we need to do is to enable the integrity check by default directly within the FA-policy-D configuration. So that's exactly what we are going to do. And we are going to restart FA-policy-D to just be sure that it will be using the integrity checks from now on. So that's exactly what we are going to do. So let's restart FA-policy-D and just see how FA-policy-D can detect these kind of changes. So we are in the same folder as before. So we are still there where the malicious software is. And we want to see, okay, let's see what's inside this file. So we are just using more like any other thing. Oh, there is something expected. So it's a binary file. So I was not expecting much more from this. But what happens is, if I copy my, I will do a backup, so I will simulate the attack, and I will use my malicious binary, and I will just, what I will do is, okay, let's exchange more with less. That is not something that is probably an attacker wants to do, but I just want to be sure that I'm able to just detect that this change happened in the system. So if I use more, you will see that, oh, there is something that is not going to work as expected, because now more is not the more that FA-policy-D knows. And think if it was a malicious binary, that would have been detected by FA-policy-D with ease. So what we've just seen, we've seen how we prevent the execution of malicious code, and if something goes wrong and the attacker is able to just inject some code into an existing binary, we can see how integrity checks can help. And in this new section, we are going to cover the second part of how we can prevent intrusion within our environment. That is called AID, an Advanced Intrusion Detecting Environment. So when it comes to file system integrity check, it's not just about the single files that happen. So while FA policy D is very focused on execution and preventing execution of existing entities, AID works in a similar way. So it has a database, so it takes a snapshot of our structure of the file system, and it is based on a sort of comparison between the actual state of the system and how the system was snapshot at the first time. So it regularly compares the current file to that baseline, and it is able to just flag any kind of anomaly. So it's not just about a file change. It also, well, the permission changed, well, the hash changed. So everything that is happening in the file system can be actually monitored by using AID. And this, of course, prevents some of the changes even in the configuration. So we can also prevent that some configuration are performed within the system. And again, we prepared two use cases for this specific demo. So the first one is just detecting and report changing on a file system. So we are going to change a configuration. And the second use case is we added a new binary in our system, and we want to be sure that AID is able to just detect this use case. So let's go with the first use case. So again, our beloved machine that we are using since the beginning. So we are still here, and the first thing that we want to do, as we said, AID is based on a database. So what we want to do is we want to initialize this database. So the first thing that we need to do is let's initialize a database, and let's make it in action. So we are going to copy the new database that was created, and we are just going to rename it as AID is expecting it to be. So it will not have the new suffix. So we are just going to create, so we are going to move and rename the file to the format that it is expecting. So that's exactly what we are going to do, and we are just giving a proper name to it for AID to just catch up with it. So now we have a snapshot of our file system and what's inside the file system, so the structure. So let's check if the configuration is still coherent, because of course we just initialized the database. It takes a bit of time, so that's the reason why we have sped up the video a bit. And at the end of the day, we will see that we are good. AID found no differences between the database and the file system. So everything looks okay. So someone got in our systems, or maybe someone is doing some nasty configurations in our host file. So this is exactly what we are going to do. We are going to change our host file by adding a line that is a malicious line, and we want to be sure that AID is able to just detect this issue and just report it. Of course, all this output and everything that we are seeing here can be integrated with monitoring tools and logging tools to just do some analysis externally. Oh, we've seen that there is something happening in the system because AID just realized that there are some entries, so something changed, someone touched the file, and we can also see a detail of what changed. So in this specific case, we see that the hash of the file is completely different and the size of the file is completely different. So something happened in our system. So that's exactly what we just seen. And this is just the first step, because at this point in time, we just detected some changes. But what if we are a malicious attacker and we want to add a binary to our file system? And this is exactly what we are going to see right now. Here we go. Our fantastic server is now ready to just test something. And let's check, first of all, if our configuration is okay. So we just want to be sure that we are starting from a clean situation. So everything looks good. So the issue that we had with the host file was solved. Our security team just checked that everything was fine. And now I want to do something that is different from before. So what I want to do is I want to take my bash and I want to move the location from where it was before. So I'm just renaming the bash as a vector, and I just want to be sure that 8 is able to detect this change. So I'm just not introducing any new binary, but I'm just creating, I'm just simulating the change. And of course, 8 can check this because we have 3 important things. So the first thing is that we have added a new file. There is the change in the directory, and also there is another file inside that specific directory. So 8 was able to just check from end to end what we had there. So if I just go and remove the file, I can just double check if something happened. And of course, if I'm going to just change it, there is no change in the file system itself anymore. So that's how 8 can help you to just take control over the directory file system structure and their contents as well. And this basically concludes this session, and I'm just passing the mic to John for another great topic that is remote at the station.
So thank you, Alessandro. I'm putting all of this together in the end of the day because we have AID and we have FA policy D to be able to check everything that's local. And quite often within our data centers. But we not only have this in data centers, we have machines sitting outside of the data center as well that we maybe want to be able to look. And these could be servers as well. And for that, we have Keyline, which is our remote attestation service that we have. So the key thing behind what we're trying to do with Keyline is looking after those servers that will typically be downstairs in the warehouse or on a manufacturing floor or sitting in a bank branch or maybe in the back office of a retail store. Those machines that's not typically part of the data center itself, but can still change and being able to be manipulated and being able to change outside of the normal realm of a data center. And again, with Keyline, what we're doing is we're creating a trusted platform, using the trusted platform module to be able to verify what is happening in the system state on that machine once it was created and put out there. And at the station, agent collects and measures everything and being able to assure that I know what is changing within the system and being able to report that back to the verifier. And the verifier going to review that against whether that system has been compromised or changed compared against the initial setup that I've created within Keyline to be able to look at the remote device itself. And remediation plans can then be executed. Maybe that change was necessary. Maybe there was an update. But quite often we can look at it and saying, no, we don't want to. And we actually want to revert the machine back into what it initially was because we got a person who wanted to install an application to do a printing job or something like that, which isn't allowed on that server. And again, Keyline, we're able to help us with that sort of remote attestation, making sure that even remote machines are within that trusted zero trust architecture that we create for our organizations. And then we're getting to something that is new. And, again, post-quantum cryptography. Why are we worried about this? Quantum computers aren't here yet. Well, not yet, but they're coming pretty fast and pretty quick. And we need to be ready for that because they are being developed so quickly, and the computing power we see behind it is so vast and enormous that we have to start thinking about what is the security risks if quantum computing comes online and how can we handle those. And again, the whole thing is being able to add in quantum cryptography into our current data policies and the current encryption mechanisms that we have within our organizations. Why are we concerned with quantum computing? Because at the end of the day, our normal RSA keys that we now have, for example, 2048 bits by default, can be decrypted by a quantum computer in matters of seconds. And that will totally expose our current environments that we have. And we will never know. Companies are harvesting our information. They're harvesting keys. They're harvesting everything. So that once they get their hands on a quantum computer, that they can very quickly decrypt these keys and be able to have access to it. And what we're doing within Red Hat is including quantum computing cryptography into the algorithms to prevent that from happening from the start. And with that, and with the help of some external companies as well that is really having good understanding of what's happening within the quantum computing field, we have created the MLKEP and the MLChem and the MLDSA keys as part of the OpenSSL standards that is now included into the RHEL 10 environment. And we're the first company and the first distribution of Linux to be able to have post-quantum capable resistant algorithms included into the environment. With the latest releases of RHEL, that is now enabled by default. And we've gone one step further with post-quantum cryptography. We're now starting to include this into the RPM packages we deploy so we can make sure that even our supply chain is trusted and verified and resistant against any attacks that we see from a quantum cryptography that might come in the future. And then to bring it all together almost is we need to look at identity management itself as well. Because at the end of the day, our security is good as how we manage the people and the access that they have, who's authorized to have it, what roles that they do. And I'm going to hand over to Angel, and he's going to tell us a little bit more about IDM.
Yeah, thanks, John. As you know, identity management is a feature of Red Hat Enterprise Linux, so you don't have to buy any product just to use it. Only deploy Red Hat Enterprise Linux, you can start using identity management. You all know that we can do a lot of different things regarding security with identity management, like role-based access control, just to specify who can access what servers cannot be accessed. A group of people, we can configure the pseudo policies as well in a central point. But we can also do any other things, like using a multi-factor authentication to provide an extra layer of security. Okay, we can use OTP, we can use OAuth2 and any other protocols just to make the login on our systems much more secure, just providing extra security based on this multi-factor authentication. But we can also use other identity providers. We can use, for instance, Red Hat Win or Keycloak to use IDN as a security provider, and we can also be integrated with Microsoft Active Directory. Just we can use our credentials for Active Directory to log in our system. And now, as a technology preview, the Azure Entra ID, the Azure Active Directory, is also supported just to be used as an identity provider for Red Hat IDN. So we can use our Azure users to log and set up the configuration and the privileges in the system for those servers that are running, in this case, in Azure. So we can use identity management just to use other sources of identity, just to provide extra layer of security, or even uses the identity we have in other systems just to access our systems, and providing other security that Red Hat Identity Management adds to our systems. But now, as you know, there's a PKI inside identity management, but it was a very, let's say, small one, because it was designed for identity management only, not as a general purpose PKI. Now we have introduced and supported the Automatic Certificate Management Environment Protocol. This protocol is used by Let's Encrypt, among others. So that means that if we have an ACMA client for our applications, we can ask for a certificate to Red Hat Identity Management automatically without no human intervention and no human operation. And then when the certificate is expiring, it was automatically reissued a new certificate to our application with no human operation. It will be all automatically done with no errors, and all the certificates will be not expire at all. So one of the problems we have sometimes in some environments, like in Kubernetes, in OpenShift, where we were using wildcard certificates due to the complexity of managing all those certificates. Now, with Automatic Certificate Management Environment supported in Red Hat Identity Management, we can provide all our applications with a certificate in an automatic way, but not only providing the certificate itself, but all the renewal of the certificate will be done automatically. So we can simplify our certificate lifecycle management with no errors and having all our infrastructure secure from the first very moment. And now I allow my colleagues, John and Alessandro, to explain you satellite.
So Red Hat Satellite is, again, one of those places where you can manage the whole estate, from the cloud environment to your on-prem, to your bare metal servers, to your edge devices, from a single environment in terms of update, patch management, being able to look at your SCAP resources, being able to get reports, be able to do remediation. As Angel said earlier, the insights tools that we see, or what is now called the Lightspeed tools in terms of vulnerability checking, advisory services, all of this sits within Satellite. And a key thing from a satellite point of view is that we start off with looking at a standard operating environment. So again, the hosts are the same across your environment. And this is key for a security point of view as well, because in the end of the day, if something goes wrong, you can immediately identify it because you are knowledgeable, you know what they look like and how they should behave. Being able to bring in reliable and resilient tools like Red Hat Insights into that. I mentioned that we have the advisory levels. The advisory will go in and actually tell you when there's issues, for example, SSH keys or security features. It will tell you where's vulnerabilities, where you haven't applied CVEs and patches, and it becomes more and more relevant today as we're starting to see a lot more attacks against our systems to be able to make sure that they are secure, that they are patched, that they're up to date, that they are compliant, that you can actually report back to your security officers with saying, yes, I have applied all the security policies and here's the report. And that you have confidence in your subscription utilization and saying, these are all the machines that are subscribed, these are all the machines that have been patched, and these are all the machines I'm ready to be able to manage and look after. And Red Hat Satellite is all about three main things. The first part is content management. So bringing the content repositories of all kinds of packages and modes that you have, curation of that, ensure that the right packages are being delivered to the right systems, that we don't get installation of packages that is not allowed in the systems, and the distribution we can do that. Lifecycle management around that to make sure that the development environments get the packages first, and then when we tested it, it goes to test, and when we finish with it and happy that it can go into production, we can push it into production. Compliance using the OpenSCAP policies, and again, we create our policies and we then create the reports around that, being able to harden the system at scale, as we spoke about before, but also get insights about which CVEs is affecting your systems, which systems are at a severe critical risk, maybe at less risk, and being able to understand exactly what is the risk and exposure you have around current CVEs that's out there. We have provision management to be able to provision that to bare metal environment. And again, as I said, this is part of the tools from the image mode, from the image builder, but also image mode, of course, in there as well, where we actually can have that images baked, ready to go with all the security tools in it, being able to talk directly to the IDM environment and to Ansible automation and being able to push that out. And then finally, patch management. And again, just making sure that we know exactly which host need updates and fixes and enhancements. We can group them together. We can have them as a group, for example, all the services sitting in our London data center and all the services sitting in our Dublin data center. But also we can say all the services part of the development environment, all the services part of our manufacturing ERP systems. And again, these ways we can be able to manage them very easy and quickly in terms of making sure that certain systems are getting updated at the right times where others may want to do some testing and so forth. And getting those patches and those updates out to the systems as quickly as possible as your security office demand that from you. And that is sort of encompassing the whole environment that we've looked at today. And again, if we go back to the previous picture, it is completing that complete life cycle. It is taking me back to that very first example that I said. You want to strengthen and secure your building, your house, your castle. This is the same to your operating systems and the Linux environment you have out there. And we've just shown you today all the tools, of a lot of the tools and things that is available to be able to do that. But it starts with, what am I going to use? What is important to my organization to ensure that I have security? Put that into the design. If I'm happy with the design, again, make sure we build this into, from the start, before we even deploy those systems out there, that they have actually functionality of these tools that we've just provided. That they run with these tools, that we can see constantly what is happening with our systems, where we have security breaches, where we have malicious software coming into, as Alessandro showed us, where we have users not allowed to access it, or users that is allowed to access it, as Angel showed us with the IDM. Manage and automate all of this so that at the end of the day, I have thousands of servers, but I have everything consolidated in a single environment where I can be able to look after it, manage it, and don't have to run into the individual machines, but I actually can see and control everything from a central point. And when I get those breaches, very quickly be able to adapt, change, put it back into my design, and go through the whole life cycle again.
And another great thing is that we've only seen the top 10 security features that we wanted to show, because there are plenty of those in each and every version of RHEL that you can really leverage and tailor based on your needs. So it was so good to see this loop finally closed, that we started with the build phase and we just manage it to the end of the life cycle.
And finally, just to say, all of these tools, and we've mentioned a few like NST and from various organizations where all of this technology comes from, and it just doesn't stay within RHEL. And then if all this technology of security that we have within RHEL goes into all our other products as well, into Ansible, into OpenShift, into our AI tools. You will find all of this in all of the Red Hat products that we have. And wrapping that up, I just want to say thank you for joining us, watching this webinar today. It has absolutely been fantastic to have you here with us. I want to thank my co-host here, Alessandro and Angel.
Yeah, thank you so much, John. Thank you so much, everyone, for taking the time to be here today. And I really thank you to Angel and John for this amazing experience together. Again, and some final remarks, Angel?
Yeah, thank you for sharing this time with us, and we hope that was quite interesting for you.
Stay secure.